again, everybody. We were discussing the mass airflow sensor in the previous video. Now I'm going to go over the scope that I was using. This is the tool I was asked what I was using. It's a portable scope. And what I was trying to convey was this was the pattern that I needed to see. Let me move this out of the way. This is the pattern of the output signal going to the computer. Mass airflow sensor. This is not a perfect square wave. Now, so you understand what this tool is or what it does. This gives you a display of the signal. Just measuring 5 volts with a voltmeter, you will not see the signal. Obviously, this is not the signal from the mass airflow sensor. I don't have it hooked up. But a scope gives you a visual look of a signal, and that's what you need. You just can't go by 5 volts. That's nonsense. You have to see the square wave. You have to see the corners. You have to see if it's rounded off. If it's distortion is the word. You have to see if there's any distortion. Now, up here, as you can see, this is the calibration that usually you do with a scope. You want to make sure you should have around actually 1 kilohertz. It's a little off. Nevertheless, this type of scope is good for the viewers because it tells you all the readings. You don't have to calculate. The old school method was, see these boxes, divisions, you would have to count divisions times this. If you want to know the frequency, you would have to count this times this. This does it for you. So what I tried to convey yesterday, obviously didn't come out that good, was the pattern of the mass airflow sensor going to the computer. Now, when I do it again, you have to pay attention to the frequency. See, everything is calculated for you. See the frequency? It tells you the frequency of this signal, this square wave. So, from the minimum point to the highest point is from here to here. Here to here for voltage. The duty cycle is how much this is compared to this. So let's say this is on time, off time, it's 50% around. See the duty cycle? 50%. And pulse width means in milliseconds, how much it is. Everything is in milliseconds. So how many boxes this way, how many boxes this way, gives you the frequency. So since they are equal, this is equal to this, they're around 50%. See? And the kilohertz frequency is around 1.1 kilohertz. Again, the voltage from bottom to top, the highest points, which is called peak to peak, 3.38. Now, there is something called voltage RMS. See, when you put your meter, when you measure 120 volts AC out of your outlet, that's terminology is called RMS. That's 70% around of the peak. So when you could put your meter, you're not going to measure RMS, you're not going to measure peak, you're not going to measure peak to peak, you're going to measure the average sometimes, unless it's a true RMS meter. That means if it's a sine wave or a square wave, it's going to give you the RMS. So when you put a meter to the outlet, you're measuring 120 volts RMS. But the meter is a true RMS meter, of a multimeter. This calculates all this for us. From here till here is 3.3 volts. If you do the formulas, it's 1.66 volts, half of that almost. Okay? So this already does a calculate. So once I see this, I look at the readouts. I'm not bothering my time to go and measure any boxes, old school method. The maximum, the minimum, the ground reference point, you see this? This is the ground. This is the ground. That means from here to here is negative. From here to here is positive. So what you see here is minimum in the negativity from here to here is 1.76 volts from here to here. The positive is from here to here, 1.62. Together, they give us 3.3. The average is this. You see how misleading it is to measure the average? You went from 3.3, correct, to an RMS value of 1.66, correct, to an average of 0. So basically it's 0, because this is equal to this is equal to this. The average of them is almost 0, because they're equal. What? So you're going to put a multimeter over there? That's nonsense. This is the tool I use. So when I put it across the mass airflow sensor, where does the mass airflow sensor go to? The computer. What's it called? The signal output. Is it a is it a input to the computer? Yes. Every sensor is a signal input to the computer. Based upon that, it's going to control the fuel injectors. They are outputs. So again, you're going to pay attention to the frequency. Make sure it changes. This is uniform. This is equal by equal. You're going to make sure that the waveform, when I put it up and I attach it, that they are equal and uniform. From cycle, this is one cycle, this is another cycle. That's why I use this as an example. So therefore, the pulse width is from here to here, or it could be from here to here. But I love this because you know what? It's easier to the viewer. You can see what this is visually, and you can see the multi-digital readouts. Almost like a multimeter. You put a multimeter, a fluke meter, it gives you the readout, 10 volts, 9 volts, right? Same thing. This is why I love it. This is the easiest thing to see. Easiest thing. You're going to pay attention to the frequency. You're going to pay attention to the duty cycle. You're going to pay attention to the volt peak to peak. Again, voltage peak to peak, top to bottom. The RMS value of that. And the average of that. And the minimum and the maximum. Right? So we're not concerned of anything more than that. We're just going to look at, make sure that these are equal for one cycle. I'll show you. Right? I put this on AC. I cut, when you put on AC, that means you cut off this is on a DC voltage also. It's on a DC voltage. That means, let me change this. See how I changed it? It's riding on a DC. But since it's running on a DC, it moves it too much up. I decided to put on AC to show you exactly what I'm talking. See how everything is uniform in this square wave. That's what you're looking for. Okay? Remember, now I hope you have a better idea. Like I said, it's hard to scream and yell where the engine is going, and this is the only way you can do measurements. Like someone said in a comment, go to closed caption, go to the subtitles, hit that button, and you'll understand. But my problem with that is you're paying too much attention to the subtitles. You're missing what I'm trying to instruct in the video. That's there's no choice. Like I just said in the previous so many videos, electronics is tough in automotive because it has to be done with the car on. You cannot take the connector out. See, some people go in and take out the connector. This is 12 volts, like we just discussed. Take out the connector, 12 volts. Oh, it's good. What does that prove to me? What does that prove? Put it plugged in. Put the connector that goes to this, the pink wire, all 3 wires. Then measure how much. Maybe this is loading down the circuit. Okay? Remember, signal first. Look at the signal. Look at the frequency. The frequency will change, will increase as I open throttle. Okay? And peak to peak, you should see they should be equal. No, you should see no spikes. Sometimes you get a spike up here, a spike down there. No good mass airflow sensor. I hope this was helpful. Next time you see this tool, you'll understand how I'm using it. Next time you see this mass airflow sensor, you'll understand 5 volts, 12 volts. Next time you see me doing an intake air temperature, how much should I get? 5 volts is the most. That's the reference. You can't get more than 5 volts. Okay? Map sensor, 5 volts. So now you understand, I hope, what I'm trying to refer to, try to convey. Please see my other video, which was about the mass airflow sensor. I told you it's going to get more and more advanced. This is high-level electronics. There is no simple way to do it. I'm trying to do the simplest I can. But, like I said, it will get more and more complex. Okay? As we go to computer signals, believe me, you have to go over the schematics. If not, you'll be lost. I try to simplify as much as I can. How much can you simplify a scope signal? And you have to use a signal scope. If somebody tells me they use a multimeter to measure this, you know what? They're off totally. Totally off. You cannot see a signal. You have to look at a signal. What do I mean by a signal? I mean a voltage that's varying with time. DC voltage is a voltage that's even, level at all time. 5 volts, it's always 5 volts with time. This is not. It's dropping a lower voltage. It's changing a voltage here, changing a voltage here, changing a voltage here with respect to time. This is time. Therefore, you have to use a scope. Then you're going to ask me, what about the AC from the outlet? That's varying signal. We don't use a scope for that. Right. You know why? Because you can measure the true RMS of that. Right? But for signals going to computers, this is something different totally. We have to make sure this is a good signal going to the computer. If we have a bad signal going to the computer with noise, guess what? The computer's not going to understand that. That noise is a problem to the computer. Okay? And another thing, when I put the ground, since this has a ground, see the ground of this? I go right to the ground. I don't want to have long wires when it comes to a scope for the ground lead. That introduces noise, especially at very, very high frequencies. What does that mean? Megahertz. We're not going that far high up. We're going in the kilohertz, right? We're not going up to 1 million hertz. Not in automotive, right? Not yet. So anyway, that's why you have to have the wire as close as possible to the component that you're measuring. All this is in a module. You're not going to see this individually. I just explained the other one. This was a long tutorial, but I hope next time when you go out there, you're going to see the signal. It's a varying signal. You're going to look at the frequency again. You're going to look at the pulse width. It's not going to be even like this. You're going to see a little spike here and more over here. That's okay. That's the sensor of a GM mass airflow sensor. That's okay, as long as they are linear unified, or equal, I guess the word is. Thanks for watching. Go to my channel, Joe Electronic Schematics. For auto, I need minutes. I need hours watched. Thanks for watching.